So today we're going to be graphing a piecewise defined function, problem type 2. So it provides us with a piecewise function, and it wants us to plug in our values, get our lines, and then we need to determine whether this function is going to be continuous. So the first one here, it says x minus 2 if x is less than negative 2. So first you would want to figure out where that first point is by plugging in negative 2. So negative 2 minus 2 is going to get me negative 4. So this first point is at negative 2, negative 4. But since this isn't equal to, it's going to be an open circle. So negative 2, negative 4, open circle. Now, there are two separate ways to do this. You could use your equation and use the slope of 1 to graph your line, which is down 1, over 1, or up 1, over 1. So another way is, since its value is less than negative 2, is to plug in the next lower number, which is negative 3. And if you do that, you get negative 5. So my next point would be negative 3, negative 5. So then I could plot that, which is here. Now, this is following that pattern of the slope of positive 1. So it's down 1, left 1, the rest of the way. And I only care about the values where it's less than 2 for my x. So this is what that part of the graph will look like. For the next one, you also want to plug in the negative 2. So you'd have 3 times negative 2 plus 2. That's negative 6 plus 2, which is negative 4. So this point is negative 2, negative 4, but this time it's equal to, so you want to fill in a circle for that one. And then it's for all x values greater than negative 2. So you could plug in negative 1, or you could have used the slope. If I plug in negative 1, that's going to get me negative 3 plus 2, which is going to be negative 1. So that's at negative 1, negative 1. So I could plot that. It fits our slope of 3 because that's up 3 over 1. So I could do that the rest of the way. So 1, 2, 3, right 1. 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 And then I'm connecting these points to get my line. So to determine if it's continuous, you want to see if you could follow the graph without having to pick up a pencil. If you have to pick up a pencil to follow the graph, then it's not continuous. So I'm going to use the highlighter on this, and I'll use yellow. So I'm following my graph, not having to pick it up. Now, sure, it changes the degree that it's going at, but I still didn't have to pick it up to continuously follow it. So the answer to this would be yes. An example of a non-continuous one would be like, let's say my graph went here, but then it picks back up here or something, and I have like open circles. It's not continuous because there's no value of negative 4 that's filled in. So that's just something to keep in mind as you go through and do these.